Hello everyone, Happy New Year, Happy Pongal. Trust everything is fine with you all. I've started getting requests on to speak on quantum computing and simplify things. So that is the reason why I thought of starting a series. So to share my understanding, because for the last 8 to 9 months, I have been academically researching on this topic after agentic AI, etc. So I will just try to share few videos. There is no plan as such, but I will try to share as many videos as it needs, and as long as my time and bandwidth supports. But in this video, I have specifically noted down 3 4 points on the basics front, so that at least you will get a feel of it, what it is, right? So these videos are unedited. I will try to upload as I speak, because I'm not getting that much of time to beautify them, or try to make it more refined, right? But my request would be to focus more on the what I speak, more on the content aspect rather than on the aesthetics, right? So slowly as it goes, I'll try to spend more time on doing these things. But what is quantum computing? When I just started asking, especially the student and then the faculty, or whomever I meet from the academic research aspect, the moment I utter the word quantum, so immediately they think of 3 4 things, right? So these are the answers that I got. They feel somehow this is too complex, and they say this is not for me, and then leave me, because I'm not I'm not at this point of time, I'm not for quantum computing. And some believe it is only for physicists, so this is something interesting. And some said that this is advanced mathematics. Some also said this is science fiction, right? These are the 3 things I noted as I just share these things with you. And let me tell you very clearly at the beginning itself, right? So according to me, my understanding says quantum computing is not magic, so it is not science fiction. So and also interestingly, I heard people telling me this is only for PhD students, and only for those kind of creamy layer, or what we call them as toppers, right? But instead of thinking that way, when we simplify things and then see, so instead of calling it as quantum computing, if you think and then call it as quantum thinking, the mindset shift gives us a lot of interest, and then let us see it that way from now onwards, right? So what I say is that what I see it is like a different way of thinking how we compute, and then I will try to draw a parallel analogy with the nature itself, how it works, so that it becomes very easy. So specifically in this video, I have noted 3 or 4 points. I will restrict the boundary to that, and I will try to explain what quantum computing really is. And then, as I always do, I will try to use common sense, and then daily life examples, so that we will be able to relate it very easily, and normal engineering intuition that we have, right? I promise I will try to avoid the formulas, so that the physics fear is gone first of all, and then the clarity remains as much as possible, right? So I will just speak whatever that comes to my mind. So there is no specific agenda that I have written, rather than 3 4 points that I noted. So I'll try to revolve my discussion in this video for 3 4 points that I've noted down. So let us just simply think, right? How computers think these days. So normal computers, your laptops, your mobile phones, etc. So we usually work day in day out with these things. Without a mobile phone, our day doesn't start, doesn't end. So and what do people feel? So we have a laptop, we have a mobile phone, and supercomputer is only for the research labs, right? So this is what our usual understanding is. Yes, it's fine. So let us stay with it for the moment. And at the deepest level, if you think, right, all of them think in the same way, right? Even the supercomputer that we're calling, which is only used in the research lab, or the laptop that we use day in, day out, or the mobile that I'm recording right now, they all just think in one way, right? The answer is they think in zeros and ones. So these are the only two possibilities that a computer can think. Right? This is how a computer can think, the way in which it can think, right? This is all we know. And now, to draw a parallel analogy, think of a switch, electrical switch that we use, right? On and off, turn on, turn off. So if you turn on, it is 1. If you turn off, it is 0, right? So that is what we do. So then now every photo that we take via our mobile phone, or every video that we watch on Instagram, or every calculation that we perform is ultimately or finally broken down into these millions and millions of tiny bits. So we are calling them as switches, right? So just to understand it very, very simply. And even if somebody asks for us to recall and then reproduce in our own words becomes very easy if you think this way. So now the point here that I'm trying to drive is classical computers are extremely fast, no doubt about it, right? But they are still forced to check possibilities one by one. When I meant, so even if they check billions per second, they are still checking sequentially, right? So this is what it does. If you, even if you're calling it as multitasking, so somehow inside the machine called computer, all the tasks are performed sequentially, right? So this is what it is. For now, let us keep this in our mind. Now, having said this, where the classical computers, when I meant classical computers, your laptop or the desktop that you use day in, day out, will struggle, right? Imagine taking, let us understand this, taking a very simple example. Imagine I wanted to find the best route between 50 cities, right, in across India. So now, so that my objective is that I will reach the destination uh, with minimum distance, right? So the problem is I wanted to find the best route between 50 cities. The objective is, the end goal is that the distance should be minimum, right? So if you give this to Google, point A, B, C, D, etc., probably it will find you, and then this is how we are trying to get an answer to this at this point of time. But imagine this is not a problem if you think sequentially, right? At the end of the day, you will just try to do it and then you will get an answer. But if you wanted to optimize it, this is not a simple Google problem, or if you have to largely look at it from a logistics optimization aspect, so this is a problem, right? So this is a problem statement that we made. Now imagine the number of possible routes is not 50, right? If there are 500, you have to spend more time, more confusion, etc. You have to spend more effort. Now it is astronomically large when it goes to 5,000, it goes to 50,000. Imagine these kind of things if Uber has to handle, if your Google Maps has to handle, or if some logistics company like your FedEx, etc., has to handle it, right? A classical computer will try to find one route, compare it, try another route, compare it. So this is what I meant sequentially. And then when we use Google Maps in a way manually, when we search it for 50 routes, this is quite possible because you're just trying to search it in your own way, in your own possible way. But as the number of cities increases, the number of possibilities, permutations and combinations grow or explode exponentially. Now, even the fastest computer, it doesn't matter how much RAM or ROM that we call you got, they still struggle, you may not be visibly seeing them, they struggle, but in the back end, when you actually see the performance, they struggle. This is not because the traditional computing is failing or traditional computers fail when this use case comes, but we have to understand the way the uh, traditional computing thinks has got its own limitations, right? The language is only 0 and 1. It can understand only the language of 0 and 1. So that's where the binary limitation is coming into picture. This is what they say, right? Now, slowly we have understood the problem. We have understood how the traditional computing understands in a language that it understands or stores the data. So now slowly let us shift without we even realizing what quantum computing is, right? So I'm not talking about definition set. I'm not talking about bookish knowledge. I'm not talking as a professor as of now, as we speak, right? So now imagine something different. So imagine you are forced to check one route at a time, but you have a way to explore many possibilities together, right? So when I meant you are forced to check one route together via traditional computing, but if I tell you, you will all you will be able to think, or you will be able to explore all 50 different routes at once. Imagine how beautiful the idea is. How we solve it is a different thing. Let us not worry about it at this point of time, right? So at one point of time, instead of thinking one route, if you are able to think 50 routes at single moment, so that is something beautiful, right? So this is where we stay. So just reflect on that idea for 5 seconds. So stay with that idea for 5 seconds. If you are able to think all 50 different possibilities at the same time, same moment, and that is how, not by force, so just reflect on that idea. This is how, even if you think the nature behaves at a smaller scale, right? So i- that's what they call. So we go deeper. I'm just trying to restrict my philosophical way of giving the analysis. But as we go, probably I can't help it. I'll try to give you, for you, a better understanding. I may try to take them as well. But the important aspect is that the way we think should change. The mindset should change. The other important aspect, quantum computing does not try to replace classical computers or traditional computing, right? So the point we have to understand here is that based on the use case, for a specific classified or a category of problems, it is extremely difficult or not so useful to use the traditional computers, right, or classical computation methods. So this is where I will try to introduce a word called qubit, right? Slowly we will understand the vocabulary. Qubit, Qubit, right? This is the fundamental of the quantum computing. We understood bits, which is 0 and 1. Now we have introduced qubit, Qubit, right? Now imagine instead of bit, what I'm telling is that quantum computing uses qubit. A bit is simple, we know it is either 0 or 1 at one point of time. But qubit behaves in a different way. Uh, uh, Imagine like this. So this is a very famous example. So that for simplicity's sake, everybody uses it. I will also try to take the same example, right? Imagine you have a coin placed on a table, right? When it is placed on a table, when it is lying on a table, there are only two possibilities, right? Either head or a tails, right? But imagine when you spin it in the air and it is halfway mid in the air, it is not possible for us to tell whether it will be heads or tails. The probability will be 50%, right? So that's a different aspect. But it is not restricted, right? There is no restriction. It can become anything. The possibilities are two, but it can become either heads or tails. So this is the important point. We are not talking about probability here. We are talking about the possibility, and there is no restriction in that thought, right? So it has the same potential when it is in the mid-air and before it reaches onto the table. It has the same potential to become heads or tails, right? So this is where the probability is 50% again, right? So now qubit is very similar. There is no rocket science here. Qubit is very similar. It is not giving you multiple final answers, so don't get confused. So finally it will have only one answer, but it is allowing you to explore different possibilities at the same time, or in the same time frame, or at the same moment, single moment. So let us not go deeper and then use another vocabulary. Now this kind of phenomenon, or this kind of theory, what they call it as superposition, right? This is called superposition. That is what I have noted there. So just to uh, uh, stay in the boundaries, or else I tend to go here and there, right? So, but do not worry about what superposition is, etc., etc. In the next videos, probably I'll try to give you that understanding, right? But as of now, more like, reflect on what I'm just speaking, because these videos I try to avoid sharing any decks, etc., or slides, because that will work, but when it is needed we will see. But as of now I don't have that idea. So let's go by the way talking, and then if you listen to this you should be able to understand, right? So because I'm just sharing my understanding, I don't have to prepare and then do those things, except that I note 3-4 words, and then I try to revolve my discussion around those things. Now there are few things that we discussed. Slowly I'll try to go into the engineering way of looking at it, right? We are not looking at one fixed answer when we do that. So when we wanted to explore multiple possibilities, when we wanted to optimize things like the route that we spoke about, right? 500 cities, when we wanted to optimize. When I meant optimization, the minimum distance between the cities, that is what is called optimization. And you are trying to simulate the complex problems, right? So this is one more thing. So now what is it? If I understand quantum computing, at least my thinking should have a shift to that level, right? So what will quantum computing, understanding of quantum computing gives me is that the way you think, you will be able to think in multiple possibilities, and the decisions become much more smarter, right? And whenever a complex problem statement is given to you, the complex combinations you will be able to solve. So this is what it is, right? So again I wanted to reiterate, this is not for everything, right? This quantum computing, my understanding is that this is not for every use case. This will only be right for the right problems, right? For the right problems, definitely it is powerful. Probably in another fourth or fifth video, or whenever it takes, or whenever I feel it is relevant, I will try to give you a few use cases and then try to give you that understanding. But uh, mm, right, so now the next important point what I wrote is that what quantum computing is not, right? So I mean, everywhere you will find what quantum computing is. My way of sharing knowledge is, if you understand what uh, what it is not, or what quantum computing is not, right? So then it becomes easy, like our MCQ questions, multiple choice questions. When we see, we will follow the exclude approach, right? So we follow our intuition. If we don't know the answer, we will exclude one, two, three. The fourth one finally becomes the answer, right? So this is the approach that I usually share to simplify. And then the other important aspect is this removes fear, right? Now, I said I will simplify. This is what it is. So, quantum computing will not replace your laptops. So, believe me, right? So, that's not the idea. Quantum computing, if used for Instagram or whatever, your Instagram will never become faster. Be very clear on that. And then I'm reiterating, you will not be able to solve every problem via quantum computing. And the other important aspect, because this is the fear, right? Quantum computing will not think like humans. Note it, and and I can speak with authority and confidence that it will not think like humans, right? Now, what exactly it is? Let us, uh, for simplicity's sake, call it as a tool, or rather a specialized tool. How do I tell it? So, if you compare a crane versus car, both are not same, right? If you understand or observe microscope versus a camera, both are not same, and then they are not used for the same purpose. Different tools, different purposes. You will use a microscope for a different purpose, to magnify and then see things. You will utilize your camera to capture memories, and then take photos, images, etc., etc., right? So different purposes, you have your different tools. Likewise, quantum computing is a specialized tool. Now, having said this and understood, now as a student, or as an early professional, or as a seasoned professional who is having some 20 years of experience and then trying to understand these things, uh, most of us may never be able to build a quantum computer, right? Let us be on the ground and then, um, you know, talk facts. We may not be able to build. I'm not saying we will never be able to, or impossible kind of a thing, but we may not be able to build. That's a fact, right? It's not needed also, which is perfectly fine according to me. But all these three categories, or when I meant students, faculty, professors, early professors, seasoned professionals, understanding of quantum computing improves your thought process about complexity. Reflect what I'm just repeating, right? You have a complex situation, your ability to think or reflect on that situation improves drastically, and definitely it will make you ready for the future technologies. uh, in other way, it will give you the ability and enable you to communicate with advanced systems, right? If you understand, probably tomorrow you may get a chance to communicate with one of those advanced systems. What are those advanced systems? Let us discuss in a different video, right? As of now, we are trying to understand why should I care about quantum computing, right? And most importantly, uh, as a technology person, day in day out who works in this industry, it will make me ready and gives me that confidence, right? That's what it is. To reiterate one more time, uh, I have never designed a CPU, but I still use my laptop or computer, right? Which is a fact. And I have never built any satellite or never worked in one of those teams who built satellites, but I'm still using GPS day in day out, right? When I start from my home, I just say hey Siri or whatever, and then I still use the GPS directly. This happens. uh, right now I think we are uh, more than 25 minutes. So I will just try to summarize what we discussed today, the 4 words that I wrote. So then in the next video, when I get time, probably I will try to speak more about my understanding and whatever I've gathered. So let us not fear what quantum computing is. I will not talk about any formulas or equations, and it is not about a separate intelligence or a different intelligence that we uh, uh, have to worry about. Simply, it is about thinking differently. How different? What is the difference? We will understand in eventually, right? So I'm just thinking in the next videos, probably I will try to uh, double click more on what qubits are so that we will get a proper understanding without even sharing any slides or whatever images. But let me know in the comments if you want that kind of a presentation. I mean, that usually works. I can do that as well. But what I thought was these random thought process sharing will give you more experienced based knowledge, right? So I will try to remove confusion about few words. There will be superposition I just mentioned today, that vocabulary, and there is one more called entanglement, right? And slowly but steadily we will try to build our confidence. And I think don't worry if you don't get all this what I spoke in one go. Try to repeat the video and then see it. And even if you understand 60% at the first time, it's okay. You will get 100% in the second iteration. So whatever I know, whatever I understood, whatever I learned, I will try to share. So if there are any small differences in understanding, so let me know in the comments, or you are free to connect uh, via LinkedIn professionally, and then probably we can discuss. So if there is something that needs a correction, yes, there needs a correction, right? So till then, I think I hope this video, if you have spent some close to 30 minutes, it should give you some idea. So till the next video, so stay curious, stay calm. So there is no need to fear about quantum computing. We will build this step by step. Thank you very much. I will see you in the next video with a lot of interesting information and the right knowledge. Thank you very much for watching.